Hey there, so you're interested in how ChatGPT was created, right? Well, let me tell you, it's not an easy feat, but don't worry, we're not gonna go all deep and technical on you because that's a sure way to put anyone to sleep. So let's keep things simple and fun. ChatGPT is what we call a language model. Basically, its job is to talk and write like a human being. But how do they even make this happen? Well, they use something called deep learning. Think of it like a really smart computer that knows how to speak and write like humans. They gave it a whole bunch of books, articles, and other texts to read and study. Then the computer started to notice patterns and connections between the words and phrases. And before you knew it, it became an expert at speaking and writing like a real human. Now, if you're thinking, hey, I want to make my own ChatGPT, well, the good news is you can. All you need is OpenAI's API, which is like a magic tool that helps you to generate text just like ChatGPT does. And the best part is you don't need to be a tech genius to use this. Well, that being said, before getting started, I got a surprise for you. So this is kind of special for my subscribers, and if you haven't subscribed my channel already, then feel free to do that because you'll get a lot of surprises. So recently I created a Tailwind CSS template that's designed to help you build your unique and eye-catching applications. As I was checking out the Tailwind documentation, I discovered that some sections were restricted and required a couple of bugs to access. But here's the kicker. I did my research and made the entire documentation available for free, and get this, it's exclusively for my subscribers. So if you haven't subscribed my channel already, then feel free to do that. So if you're looking to learn Tailwind CSS, yeah, I'll leave that link to that template down below this video description. By the way, if you like this template, don't forget to give a start to my GitHub repo. I'll just leave that link in the description as well. Alright, let's get started with creating our project. First, we need to create a package.json file, which is a configuration file for our project. To do that, we'll open up the terminal and enter npm init with the y flag. Once that's done, we'll paste all the dependencies we need into the file using the same version that we are using to avoid any errors. Now, let's add the script tag and say the start script to nodemon index.js. Nodemon is a tool that helps developers save time and work more efficiently by automatically restarting the program every time changes are made to the code. Moving on to the index.js file, we'll import some external modules including Express, Cookies Browser, Course, Mongoose, and HTTP. These tools will help us to create a web application with ease. Next, we'll create a root folder, and inside that we'll create chat.root.js, index.js, and user.root.js. We'll work on these files later. For now, we'll head back to the index.js file in the root folder and import a root file called index.js that we created earlier. This file contains various API endpoints that we'll set up later. We'll then set up the instance for Express app and use some middleware functions provided by Express, including course, express.json, express.url encoder, and cookie phraser. These middleware functions allows the app to process incoming requests such as parsing request data and cookies. Next, we'll set up a route to the API endpoint, which will use the imported routes from the index.js file. The app is then set up to listen on a specific port, which is either the value of an environment variable called port or 5000. If the variable is not set, we'll create a server using the HTTP module and pass the app to it. To connect a Mongo DB database, we'll use a Mongoose module, which provides a simple and efficient way to interact with MongoDB database. If the connection is successful, then the server starts listening to an incoming request on a specific port. If the connection fails, the code will log an error message and exit. Now let's create an env file in the root folder and define our MongoDB URL, token secret, and OpenAPI key. To use OpenAPI key, we'll go to the OpenAI dashboard and create a new key, which we'll paste inside the env file. Note that this API key will only work when you add the payment information on your account. We'll also create an gitignore file to ignore all the secret API keys on the .env file. Back in the index.js file in the root folder, we'll import the Express module and two other modules containing user.root.js and chat.root.js, which are two separate modules containing routing information for the /users and /chats endpoints respectively. To set up a new router using Express module, we can use the express.router method. This router will define two routes, /users and /chats, and for each route we'll use corresponding imported modules. For example, when a request comes in for the /users endpoint, the router will use the routing information defined in the user.root.js module. Before moving on to the user.root.js module, we need to create a utils folder in the root directory and then define a middleware function for validating incoming data in an Express.js application. For this, we'll create a new file called validated.js inside the utils folder. In this file, we'll import a function called validation result from the Express validator module, which will be used to check the result of data validation performed by a previous middleware function. We'll then define a new function called validate that takes 3 parameters, rec, res, and next, which are standard parameters for an express middleware function. Inside this function, we'll check for the errors in the data validation results using the validation result function with the rec parameter. If there are errors, the function will return an 400 HTTP status code and error message in JSON format that contains the message of the first error encountered. If there are no errors, the next function will be called to move the request to the next middleware function in the chain. Next, we'll create a file called user-model.js in the user model folder. In this file, we'll define a user schema for Mongo DB database using Mongo's library. The user schema will have 3 fields: username, password, and salt. The username field is a string that is required and unique, while the password field is a string that is also required but marked as select false, which means it will not return by default in any database queries. The salt field is a string that is also marked as select false. The user schema will also define 2 methods: set password and validate password. The set password method will take a password as input, generate a random salt using the crypto library, and use the pbkdf2sync function to hash the password with salt. The hashed password will be stored in the password field for the user schema, and salt will be stored in the salt field. The valid password method will take password as input, use the same pbkdf2sync function will be stored salt to hash the input password and check if the resulting hash matches the stored password hash. If they match, it will return true, indicating that input password is valid for user. Finally, the code will export a user model based on user schema, which can be used to perform CRUD. That means create, read, update, and delete operations on user data in the MongoDB database. Next, we'll create a middleware file named token.middleware.js inside the middlewares folder. In this file, we'll import JSON web token module and the user model from a separate file in the application. The token decode function defines in the file takes a request object as input and attempts to decode the token from the authorization header of the request. It uses the JSON web token module to verify the token and returns the decode token if it is valid. If the token is not present or is invalid, the function returns false. The token auth function defines in the file takes the request, response, and next function as inputs and is responsible for creating the validity of token. It first calls the token decode function to decode the token from request. If the decode token is false, the function returns a 401 HTTP status code and an error message in JSON format that says token is invalid. If the decoded token is valid, the function uses the user model to look up for the user associated with the token by calling user.findById. If the user doesn't exist, the function returns the same error message as before. If user is found, the function attaches the user object to the request object and calls the next function in the middleware chain. This way, the authenticated user can be accessed subsequent middleware function for that endpoint. Now, let's create 2 different files inside the controllers folder named user.controller.js and chat.controller.js. In the user.controller.js file, we'll export 2 functions for user registration and login. The user registration function handles user registration when the user submits the username and password. This function first checks if username is already taken. If it is, it returns an error message that the username is unavailable. If the username is available, a new user object is created and its password is set using a salt and a hash. The user object is then saved to the database and the success response is sent back to the client. The user sign-in function handles user login when the user submits the username and password. This function searches the database for a user object with a given username. If the user is not found, it returns an error message. If user is found, it checks if the password matches the hashed password stored in the database. If password is incorrect, it returns an error message. If password is correct, it returns a JSON web token JWT using the user's unique ID and a secret token stored in the environment variables. The JWT is then sent back to the client along with the user's username and ID in a success response. The client can use the JWT to authenticate subsequent requests to protected routes. Now we'll move on to creating a chatbot response function in chat.controller.js. We'll call this function chat completion and it will handle a post request to create a chat response using OpenAI's GPT-3 language model. To connect the OpenAI's API, we'll use OpenAI API class from the OpenAI library and create an OpenAI config object using the API key stored in the environment variables. When the chat completion function is called, it expects a prompt string in the request body. It then passes the prompt string to the OpenAI.createCompletion method along with some additional parameters such as the language model to use the temperature and the maximum number of tokens in the response. If the request is successful, the function extracts the chat response text from the response object and sends it back to the client as a JSON object with text property. If an error occurs during the request, the function sends an error message back to the client with the 500 status code. Now, let's get back to a chat.root.js file in the roots folder, where we'll define an express route for handling HTTP post request to the /endpoint to generate a chatbot response. We'll use the token auth middleware to verify the authenticity of the request. If the token is invalid, the middleware sends a 401 unauthorized response. If the token is valid, the request is passed on to the chat completion controller function. We'll also use this router file in the user.root.js file for handling the user authenticated related routes. In the /signup and /signin routes, we'll use the body method to validate the usernames and password fields in the request body. If the validation fails, the validate middleware sends a response with an error message. The user register and the user sign-in functions are the controller methods that handles user registration and user login requests respectively. We also use the token auth middleware function to verify the JWT token in the authentication header of the request. If the token is valid, it adds the decode user information to the rec object. Finally, we'll define a check token route that checks if token in the authentication header is valid. If the token is valid, it sends a response with the username of authenticated user. Once we have got everything set up, we can open up the terminal and run the server by entering npm start. Alright, let's get started by creating a client-side application. To do so, we'll use the white app, which we can easily set up by typing npm create white at latest and selecting y to confirm. Then we'll create the project name and choose the JavaScript version, and we'll be all set to start building the application. Next, we'll add the necessary dependencies and development dependencies to the package.json file and install them. After that, we'll create a new file called axios.client.js in the API folder to set up an HTTP client for making requests to REST API, the base URL. This file will also include two interceptors, one for adding header to every request with a JSON content type and an authorization token obtained from the local storage, and another for intercepting the response, extracting the data from it, and returning it as the response data. This configuration will allow us to make requests to that specific REST API using Axios. Moving on, we'll create a new file called chat.api.js to export a function called chat completion that sends a post request to the /chats endpoint of the server using the Axios client instance created in axios.client.js. The prompt value is sent as a request body, and if the request is successful, the function returns an object containing the response data, otherwise it returns an object containing error information. We'll also create a new file called user.api.js that exports three functions, namely user signup, user sign-in, and user token, each of which makes a request to the server using the Axios client instance created in axios.client.js. The user signup function sends the post request to the API with the username and password provided as arguments, while the user sign-in function sends the post request to the API with the same arguments. The user check token function sends a get request to the API with an authorization header containing the JWT token stored in the local storage. Now, let's set up the components. We'll start by creating a new file called header.jsx that contains a React component called header. This component takes in some props to customize its appearance and uses the Material UI library to create a rectangular box with a background color and an optional border at the bottom. The content of the header is passed in as a child element. Let's move on to the next step in setting up the app. First, we need to create a new file called loading.jsx where we'll define a component that displays a circular progress indicator in the center of the screen using MUI's libraries box and circular progress components. After that, we'll move on creating a protected root component in a file named protected.root.jsx. This component checks whether the user is logged in by verifying the presence and validity of a saved token in the local storage. If the user token is valid, it allows access to the page, otherwise it redirects the users to the login page. While the component is checking for validity, a loading spinner is displayed on a screen. Next up is auth_root.jsx, where we'll create a component that checks whether a user is authenticated by verifying the token in local storage. If the token is still valid, the user is redirected to the home page, otherwise the user can continue accessing the component. The auth_root component can also display a loading spinner while checking for the token's validity, and then renders a header, the props, children, and a footer with a link to a YouTube channel. We have already designed the pages, so we can import them into our code. Moving on to app.jsx, we'll define three pages: the home page, sign up page, and sign in page. The home page is protected and can only be accessed by logging in users, while the sign up and sign in pages are not protected and can be accessed by anyone. In the app component, we set up the application's theme and wrap the various routes in the browse router and router components. We'll also include a toast container for displaying toast messages. Finally, we'll create a new file called main.jsx where we'll render the React app onto the web page using the react dom.createRoot method. We're also importing different styles of Roboto font to use in this app. The app is wrapped in a react.strict mode to help catch potential problems and warnings early. Once you have completed all these steps, you can see that the app is now working, and you can customize the app according to your preferences. If you have any questions or concerns, feel free to comment down below, and I'll catch you guys in the next video. Peace.